Really quick. So Mike, welcome to the Seattle Crafter Meetup. Looking forward to a great talk about pulling great metrics out of Jira. I'll hand it off to you.
Okay, perfect. So after that introduction about behavior and such, we're not going to talk about any of that. We're going to talk about metrics instead. Most of my clients use Jira, and if you are using Jira, you'll realize that it has a bunch of built-in reports, but almost all of them are broken, and they're generally not all that useful. So I needed, as I'm coaching teams, I needed good metrics so that I could give feedback to the teams so that I can help them improve. Because if we don't actually know what our current state is, it's very hard to figure out what the next state should be. So I needed good metrics, and the tool was giving me all of these poor metrics to start with, and most of them were broken in ways that we'll talk about in just a moment. So I built a tool that allows me to extract them, and now that we have access to that, we can make better decisions for ourselves. And that's really the essence of it. So we're going to be walking through, this is not about the tool per se. This is about the metrics and what we can learn from the metrics once we've extracted them. All right. So we'll spend a few moments just talking about what Jira currently gives you and why it's not helpful. This is the Jira control chart. It's very pretty, but it doesn't actually give us any useful information. If we look at the y-axis down the left-hand side, we can see that you would assume that this would be a linear scale, but in fact, right now, it's not a linear scale. It is actually a cube root power scale. But if you were looking at less than 30 days, then it would be a linear scale. So you have to look very closely to see what it is. And quite honestly, most people are just confused by a cube root power scale. And so right off the bat, we're misleading people with information. Then we've got this blue area in the back that is supposedly the standard deviation of the work that's coming along. But the problem is that from a statistical perspective, standard deviation only works if we have a standard distribution of data. And the kinds of data that we're trying to plot here is not a standard distribution, it's a Weibull distribution, which means that standard deviation is meaningless in this context. It looks pretty. We got this nice blue area in the background, but it's not telling us anything that is actually actionable. Then we come along to Jira's cumulative flow diagram, and a cumulative flow can be a great and useful tool, particularly for a team that's doing Kanban. It tells us things about how much work was in each state at each given time and lets us see patterns. And this is all great, but by definition, a cumulative flow can never go down, and yet the Jira one does. So it's not accurate. It's mostly accurate. So if we want to look at the data, we can mostly get a sense of where things are going, but it's not 100% accurate. So if we're trying to make actual, real, actionable decisions from this, we have to recognize that the data may be wrong. So let's talk about what it means for data to be wrong and why we really care about it. If we were to do a hurricane forecast based on the data that we have up in the top left here, we could make really good, accurate forecasts about where that hurricane's going to go and what direction it's going to go. And with 85% probability, we can go this way or go that way. And that's good data. It's reliable, it's consistent, we can make good decisions. Sure, there's outliers, but we can make good decisions based on what's out there in the top left. But if we look at the diagram in the bottom left, we can see that the data is absolutely useless. Everything is all over the place. And so if we try to make decisions based on that model from the bottom left, we're going to come to the wrong conclusions because our data was inherently wrong. And yet, when we look at a pretty chart, we have all of these cognitive biases that make us believe that what we're seeing is in fact accurate. So we need to be very aware of what the data is and whether or not it's useful enough to be able to do that, to make decisions off of. You will notice as we go along, you'll get a link to this board later, but these are links to other things. So, for example, there's a link here to cognitive biases in general, survivorship bias very specifically, which tells us things like how much of the data are we not seeing. So you will see those links and you'll be able to click to those later. So the first thing that my report brings up is an idea of how accurate our data is for exactly this reason. So if I'm looking at good predictable data, then I can make actionable decisions that will help us improve. But if my data is all over the place, then it doesn't matter what decisions that I make. They're based on flawed data, and therefore they're not going to be as helpful. So step one in looking at what we get out of Jira or out of whatever ticketing system you're looking at is to understand how accurate your data is. Is it actually good or is it not? And so the first part of what this report comes up with is it tells you all of those places that the data is inaccurate. So we can see, for example, that in this particular report, 23 items were discarded from all the charts that use cycle time because we couldn't tell when they started. We knew when they finished, but we didn't know when they started, and therefore we can't know anything about those items where we didn't know the start date. These are things that went straight from to do all the way to done with nothing in between. So we didn't know when it started. And so in this case, that means that only 73% of our total data points are actually showing up on the chart. So we look at the chart and we think we can see very clear patterns, but we need to recognize that we're not seeing all of the data. We're only seeing 73% of the data in this particular case. And so we have to question, is that enough for us to make good actionable decisions, or is it just wildly inaccurate? Now, 73, I might think that's good enough, but if that was at 23%, then I'd be saying just throw the charts away. The data is completely useless. It's not telling me anything useful. So that was a data that was discarded. We also see examples of items moving backwards across the board. We really don't want items moving backwards because in the case of our data, it skews things. So we might say, well, this item got all the way to done, and then we moved it back to in progress again. Or it went from to do into in progress, and then it moved backwards back into the backlog again. The numbers that we're presenting in the charts are going to be completely useless in this case because it's going to be throwing away data. If I have an item that started, we left it in progress for 3 weeks, and then we moved it back to the backlog, and then we moved it into in progress again. Are we tracking the 3 weeks that it had been in progress the first time? Maybe we are, maybe we aren't, but we don't really know. And that's the essence of the problem. So this is calling out where we have issues. All right, so moving along. So here are the things that this particular report looks for. There might be other things that you care about. It's items that were moved back to the backlog after being started, which is incredibly common. Items for where we know when it completed, but we couldn't tell when it started. This is, again, fairly common. We see this for most teams. Items that continue to have status changes after being completed. This is rarer, but we still do see this. So we have one column on the board that is done, where we stop the clock, and yet there's still status transitions that happen after that. So for example, a team might say, we're done when we have done our part, but it hasn't been deployed to production yet. That's a separate status change. So this report is calling that out and saying, well, you kept working on it after you said it was done. So does that actually make our cycle times invalid? It probably should. So this is feedback to us. Items that move backwards, items that are done before they even started. I've seen cases where boards are so badly misconfigured that the moment a new item is created, it's created in done status, and then it gets dragged back to do. I've seen that actually with a couple of teams. So there's some very wildly, crazily configured boards out there. Items where the item itself is showing that it hasn't started, and yet some of the subtasks have started. We've actually started moving subtasks across the board, but the main story is not moved. That's clearly a problem. And conversely, items that have been declared as done, but which still have subtasks that are moving around on the board, that's also almost certainly a mistake. And then the last one here is items that show up on multiple boards, and so are likely showing up in multiple metrics, and it's probably a mistake, but it's hard to tell. All right, so let's move on. Let's talk about what kinds of metrics we would want to see first of all. The basic flow metrics that I care about are these four. And these four balance each other out. So what we can see that two of these are on items that are not yet finished. Those are the two on the left. Two of them are all about work that is finished. That's the two on the right. Two of them are all about the system, aggregated work. Those are at the top. And two of them are all about individual work, the two at the bottom. So we have this overlap across the four. And the four are work in progress, just how many items are started but not finished. Our throughput, how many items have completed. So if I'm in a Kanban system, I might say how many items completed each week. If I'm in a Scrum system, I might say how many items completed in each sprint. But either way, it's throughput. It's items completed over some period of time. Then we got cycle time, which is how much time did it take? How many days was this active for? So if I started an item today and I finished it today, it's a 1. It was active for 1 day. If I started it yesterday and I finished it today, that's a 2. That's all we're tracking, just how many days was it in progress. And the last one is work item age. So this is for an item that's not yet finished. How long has it been since it started? So work item age. And I really want to see all 4 of these so that they balance out against each other. Because if I only look at one, I'm going to get a somewhat skewed and misleading view into the entire system. So having all 4 of them allows me to get a much more balanced picture. If for some reason I couldn't look at all 4, I would probably want to start with age, because age is the single one where I can make a rapid decision. I can't make any decisions around cycle time or throughput. I can't just decide that my cycle time will be shorter, but I can decide that I'm going to finish this item today. So I can work on age. There's decisions I can make around that. There are decisions I can make around WIP as well, but only in the sense that I decide whether I'm starting a new piece of work. I can't decide to finish one. All right, so let's look at the actual data. So this is the cycle time scatter plot. What we're looking at here is each dot is a specific item. And what we're seeing is along the x-axis, we've got the date that it actually completed. And along the y-axis, we've got how long it had been open for at the time it closed. So what was its total cycle time? And we can start to see patterns. We can see, for example, that on October 29 here, we had an outlier that was way up here approaching 30 days. Most of the work is happening at a lower, is happening faster than that, but we do have the occasional outlier, and it's worth calling those outliers out. We can see from this that 85% of our work, of our stories completed in 8 days, and 85% of our tasks completed in 2 days. Now, you might be wondering why 85%. There's nothing magical about that, other than 85 is a reasonable proxy for most. So we can say most of our stories completed in 8 days or less. Most of our tasks completed in 8 days or less, in 2 days or less. And we can see on this chart where those lines are. The solid blue line across are my 85% for tasks. My solid green line across is my 85% mark for stories. We can also see the dashed lines that are our trend lines. So we can see that for this team, that our trend line is going down. We're actually completing things faster for this team. Even though we have some outliers up here, in general, the work is trending downwards. Things are getting faster, and it's the same for tasks. This is a really good sign for this team. So they are actually getting better at completing the work. They're getting it done faster. And that's a very positive trend. Just a quick note, the gray background here is the weekends, so that we can tell at a glance how much time has passed. This particular chart is 90 days, but it's configurable. Things that we might look at in this chart, if we saw, which is quite common, if we saw a rise in numbers where the numbers are coming up on an angle like this and it's getting higher and higher, that would indicate that the system is not yet stable. And that perhaps we just started using Jira, or we just started, this is a new team. And so we're noticing the system's not stable yet. So if we wanted to make predictions about when will things be done, we wouldn't be able to do that. Whereas this team here is largely stable. Again, the trend line is going down, which is a positive thing, but it is changing, which means that the system is not as stable as we might hope. If it was perfectly flat across, we would be stable. We'd be able to make better predictions. So let's take a look at the histogram. The histogram is when we are looking again at cycle time. So how many days did it take for the work to complete? But we're looking at the frequency distribution. So we can see that a lot of our items completed here in 1 day. And we have a number of items that completed in 2 days, far fewer on 3 and 4 across here. And we can see that there's definitely some patterns. We've got one type of work that takes place that gets done in 1 or 2 days. We have another type of work here that's taking a little bit longer, and we might have a type of work that's way out here on the outliers. It's hard to tell. There aren't enough data points out here for me to say definitively that this is a new type of work. But we can start to see these humps that when we get things clustering together, that's probably a different work item type. And the type, it could be a type in terms of intent, like whether it's a story or a bug, or it could be that the work that's down here has no real dependencies on anything. And this work here are things that have dependencies on another team or have some kind of a governance structure. There's something that's different about them than these teams over here, these work items over here. And so it gives us a sense. We can start to look at groupings and we can start to have conversations. Well, if we're having a lot of these ones out here, maybe we want to dig into that a bit and find out, well, why do we have that cluster of work around that point? Is there a dependency that we could break? Is there some kind of governance that perhaps we could loosen? Is there something we could do to get everything down to these times? Those are the kinds of decisions we might make off the histogram. So then we'll look at throughput. Now, in this case, I'm graphing throughput in two different ways. On the top chart, this is the same team in both cases, but on the top chart, I'm grouping everything according to what type it was. So we have some stories, some tasks, some defects, and then the gray dashed line is the total number. But we're getting some kind of a breakdown. We can see that we don't have a lot of defects here. That doesn't mean that this team has high quality. It means that they've only worked on one defect in this time. They've only finished one defect across this entire period. But that doesn't mean that they only worked on one because they had really high quality. It could be they only worked on one because they're completely ignoring bugs and that they're racing to get other stuff done and they've completely ignored quality entirely. So this doesn't tell me anything about the quality of our system. It just says we've only worked on one bug in this, we've only finished one bug in this 90-day period. The bottom chart tells us how we closed off the work. And in some cases, every team closes them off the same way, and in other cases, they don't. This particular team that we're looking at had multiple different ways of closing off tickets. So we might say, well, some things are marked as fixed, completed. Some things are completed, fixed, completed. Some are accepted, fixed, completed. Some are accepted as a duplicate. Some are closed as a duplicate. So they had multiple different ways of what the different statuses that they use, which is what comes before the colon, and different resolution names, which is what comes after the colon. So they had multiple different ways of closing it. And sometimes that data is very useful. We might start to notice, well, we have a lot of issues that are closed as duplicates. So maybe we need to do something in our process about vetting the work before it actually gets entered. Is if we have a lot of duplicates or we have a lot of won't fixes, then maybe we have a problem upstream and that we shouldn't be allowing so many tickets to be entered into the system. So it's feedback to us about the way we close off the ticket. So now let's take a look at that was completed work. This is now work that's actively in progress right now. So we're looking across a specific board. We can see that this team has multiple in progress statuses. They've got development, code review, business acceptance, deployment. And right now, there are only 4 or 3 items actually on the board, plus 1 item that's not visible on the board. The unmapped statuses means that this is just not visible at all. And likely we've forgotten about it. That's probably why it's up here at 24 days, is because we've completely forgotten that that item was even there because we can't see it anymore. The gray area in the back here is our 85% point. So we can say that statistically, of all of the items that have moved through this board in the last 90 days, 85% of them have left development in 6 days. 85% of them have left code review in what looks like 7 days here. They've left business acceptance in what looks like 9 days. They've left deployment at what looks like about 12 days. So this gives us feedback. We can see right off the bat, these two are outliers. Even right early on in the system, they're already taking longer than most work does. And so perhaps we want to jump on these. Perhaps there's things that we need to do about these 2 items. I'm not so concerned about this one because it's still within the area that most work has gone. So perhaps this one's not a problem, but these ones up here are absolutely a problem. They're already outliers and they're still in the first column on the board, the first in progress column. So looking again at aging work, but we're looking at something slightly different data. Each item that's here could have all this data has been fully anonymized, by the way. So these are just randomly generated words. Don't expect that anybody actually typed that in. We could potentially have three bars here. The top bar is the status that it's currently in. The middle bar is whether it's blocked or stalled. And the bottom one, if there was a bar here, none of these examples have them, would mean that it was expedited work. So we made it a higher priority. We decided this is more important than anything else. But what we can see that's interesting on this board is that this item here, although it's been open for 24 days, it's been stalled that entire time. So we moved it to in progress, and then we did nothing else with it. We haven't added a comment. We haven't changed the status. We haven't moved a subtask. This item has been idle the entire time that it's been sitting on the board, and that's fascinating. This is feedback to us that perhaps we need to do something about this. Now, it doesn't mean that we truly ignored it, but it does mean that nobody updated Jira with anything. So if we are working on it, nobody's gone back to add a comment, to move a status, to do something, because again, all the data tells us is what's going on. It says nothing happened in Jira for this ticket, but somebody might legitimately have been digging into it. Either way, it's feedback. It tells us we may have a problem here. Whereas this one's been open for 7 days, but people have been working on it the whole time. There's no idle time in that one. All right, moving along. Again, more aging data, but it's a little bit different. We're providing a little bit more structure. We're saying these items belong to a hierarchy. So we can say that this story here, Scraggly Ridge, belongs to this epic up here. And if we had multiple levels, then it would show the entire hierarchy all the way up. Because sometimes it's useful to know what epic that belongs to. And we'll get more to epics a little bit later, because the epics should be our high-level focus of what's going on. And being able to see what epics we have in play is a useful thing. We can see that in this case, two of the stories that are on the board right now belong to the same epic, and the other two belong to different epics. We can see that this one is currently blocked. We can see what status it's in. The little googly eyes here indicate that this one is not on the board. So we've noticed that before. It's not visible on the board. Likely we've forgotten all about it. All right, so now let's take a look at work in progress. So the four main uh, uh, flow metrics that we talked about, work in progress is one of them. These are items that have started but have not yet finished. We can see a number of things for this team. We're looking at aging work. So we can see that items that are in gray at the top, I don't actually see any grays, but if there were anything up here, sorry, up in the brightest of yellows, they just came in today. I'm not worried about stuff that just arrived today. I am worried about stuff that's been around for a while, so that we can see that these items down here, they had been open for 4 weeks or less. Now, we don't have anything more than 4 weeks, which is a good thing on this particular chart, but quite often when we come in, we see that there's some items that have been here for a short time and some items that have been around for a long time that we've just been ignoring. We can also see the pattern that this team, over time, has been taking on more and more work. They've got more things in progress at the end than they did at the beginning. We can see the trend line going up. And this is generally a bad thing. As our WIP goes up, what we generally find is that we become less efficient at actually getting things done. We find that our quality drops. And we also find, interestingly, that business prioritization goes out the window. And I'm not going to spend a ton of time talking about that last point, but I will point out that the business goes and spends all kinds of time making sure that we're doing things in the right order because we have prioritized the work that's coming in. And when we have too much work in progress, all of that business prioritization goes out the window. And what happens instead is that we end up delivering the small items before the big ones. And if you want to know more about that, I'd be happy to dig into that another time. But generally speaking, the higher the WIP, the less effective we are at delivery, the lower our quality is, and the less business prioritization actually made a difference. So we want to keep our WIP under control. Now, this team is not too horrible. We see that they cap out at 14 items in progress, but most days they're lower than that. They're down to 6, 7, 8 maybe items here, which is probably about one item per person. I've seen teams where they had 10 items per person on the board. The worst I've ever seen was a team of about 10 people with 227 items in progress. They were completely overwhelmed. Nothing was getting done. It was a complete disaster. That was the worst I've ever seen. This team that we're looking at right now is actually not too bad. A couple of other things that worth calling out. The ones in white up here are places where we don't know if the work was actually in progress that day because we can't tell when it started. The only thing we know for sure is that it didn't start earlier than the ticket was created, and it didn't start later than the completion time. That's the only thing we can say with certainty. So the white is a bit of a guess as to how much work was in progress on that particular day. The greens on the underside are the items that got completed on that day. So it gives us a sense of when work was actually being completed.
So you're kind of pointing out Little's law there.
Sorry, say that again?
Oh, you're pointing out Little's law. The more items in progress, the longer our
Yes.
cycle time.
Yes,
Yeah, and I
yes.
think that the CFD is probably the best view for that.
They all give us a slightly different view, and having multiple different charts that look at the same data the same way can be helpful.
Thank you.
But yes, you're absolutely right. We're showing the relationship of Little's law here. All right, so this is the same data, but we've grouped it differently. On this chart here, we're grouping everything by how long it's been open. And on this chart, we're grouping it based on whether it was active, blocked, or stalled. And so we can see that we've got items down here that are blocked, the dark orange. We've got a lot of items that are stalled, and we've got blue items that are actively in progress right now. We're actively working on them. So we can see that in this period of time when this team was getting busier and taking on more and more and more, the reality is they were actually working on very few of those. Most of this stuff was just stalled. It was sitting there. We were ignoring it. And that's, again, feedback to the team. Why did we start it if we aren't going to finish it? And you might say, well, maybe they were just blocked on things. Well, then they should have marked it as blocked. Blocked is very different from stalled. Stalled means we don't have the capacity to work on it because we're too busy with this stuff up here when we should be focusing on the stuff that had already been started. All right, so I mentioned epics earlier, and this is an interesting view here. If we've sliced our epics properly, and a lot of companies don't, a lot of companies just say an epic is just a bucket of stuff, which is a poor way of doing that. But if instead an epic was actually a unit of value at a higher level, then tracking how many epics are in play at a time gives us valuable feedback about our focus. It tells us whether we are highly focused on one thing and trying to get that one thing done, or if our focus is all over the place. Now, this particular team is not too bad. We can see that through this period, they were mostly focused on the purple epic. They did a couple of other things here and there, but mostly they were trying to get this purple epic up here to done. And although they did get distracted periodically, they were really focused on that purple one until we got up here, and then this darker green got a bit more priority. And then clearly purple is finished, and we got into this lighter green one, and we got focused there. So this is a team that's fairly focused. But I've seen teams that across a 90-day period have got hundreds of epics in play. And what that tells me is that we have no focus at all. Our attention is all over the place. We're trying to do a little bit of this and a little bit of that and a little bit of the other thing. And the reality is that when we are that unfocused, we're really not getting anything done in an effective way. So this can be a really interesting view, but only if we've actually sliced our epics in reasonable ways, which all too often doesn't happen. Often we'll just say, well, the epic is a bucket of stuff. Here's an epic for bugs, and here's an epic for new stories, and that doesn't help. All right, so we talked about these four, and I've shown you a whole bunch of charts about how we could do work in progress and throughput and age and cycle time. And that's all great, but what else does Jira have? Because Jira actually does have a lot of really interesting data internally that it doesn't do a good job of exposing. So before we get there, let's take a look at, well, why would we even want to look at other metrics? And the reason we want to do that is because we want to be optimizing our system. We want to be getting better over time. And in order to get better, we really want to make sure we're focusing on the right things. So what's the reason that we want to get better? How specifically do we want to get better? And what we should be doing is balancing across the three green circles here, across efficiency, effectiveness, and predictability. Effectiveness is all about getting the right work to the customers when they need it. So we've delivered the right value to them so that they can do the things they care about. Predictability is all about making sure that we can anticipate. So when somebody comes to us and says, when will you be done this big chunk of work? We can give them an answer. And that they might need that because when we roll out this new feature, we also have to run a marketing campaign. Or when we roll out this feature, we want to make sure that this other team, the help desk, is ready to support it. Or we might just say, we've got a fixed amount of money and we want to make sure that we've actually rolled this feature out before the money runs out. So it's quite reasonable to answer the question of when will we be done? And we have to optimize the system to make the data inherently more predictable or less predictable. So that would be effectiveness and that's predictability. Efficiency is interesting because there are, in fact, two different kinds of efficiency. And when we just say we want to be efficient, we're not always talking about the same thing. What we should be optimizing for is flow efficiency, which is keeping the work moving, getting the work to done. But what we often talk about instead is resource efficiency, which is about keeping the people busy. Are our people busy enough? Does Amy have enough work? What's Bob working on right now? That's all about resource efficiency, making sure that our people are busy, which counterintuitively makes us worse at flow efficiency, which is actually getting the work done. So we can either be focused on how busy our people are, or we can be focused on how much work actually gets done and when it gets done. So we want to be focusing on flow efficiency. We want to stay away from resource efficiency. But again, I could spend the entire time we've got here just talking about that particular thing. But just focusing here, this is what we're trying to optimize for. So flow efficiency is an interesting thing. If we want to actually measure it, measuring flow efficiency is incredibly difficult because it's a very invasive measurement. But if we look down in the bottom right here, how we might want to measure it, it's the ratio of how much time we spent adding value divided by the entire time that we spent. So on the green, we might say, well, we're in design for a short time, and then we sit around waiting. And then we do something in defining and we sit around waiting. And we do something in dev and we sit around waiting. So it's that ratio of how much time did we add value divided by the total amount of time. We might say we spent half an hour over 3 days. That's our ratio. So if we graph that, it becomes interesting and we start to see graphs like this. Now, a lot of the data is going to be wrong because, as I mentioned, collecting the data correctly for flow efficiency means that we have correctly entered into the system every time we started and stopped working on a ticket. So I'd have to mark it as blocked as the moment I stop working on it or move it to a status that indicates that we're not working on it as soon as we go. And most people don't do that. Most people don't track that level of information. But if you did, then we would be able to do interesting things like graphing flow efficiency in this case. So we can see that there's a lot of work in the green here that showed itself to be 100% flow effective, which is not the reality. That's really what's most common is that we have less than 10% flow efficiency for a typical team. But what in this particular chart, and in what I'm seeing from most of the teams that I graph this for, is that we get some things that say that they're 100% flow efficient, and they tend to get done in a fairly consistent way. So we can start to see. And then we have a whole bunch of items that are less than 30%, and we got a couple of things in between. And I'm noticing this pattern. I don't know if it's going to hold true across all teams, but for the teams that I'm graphing this for, this is the pattern that I'm seeing. A lot of things pretending to be 100% flow efficient that are getting done fairly quickly. About 30% of the things that really aren't, and a couple of things in between. So if you really cared about flow efficiency, we would have to make sure that our board was set up in such a way that the team could move things in and out of that active status at the right time. Very invasive, but it's an interesting number to measure. All right, so now let's talk about expedited work. I've just in general, teams tend to overuse priorities. I've noticed that Jira by default gives you 5 different priorities going from low, I think it's lower to low to medium to high to higher. Out of the box, it gives you 5. And when people use all 5 priorities, we can't tell in the data what those priorities actually meant. So if I were to graph out all the cycle times and color code them by what priority they were on, for every team that I've looked at so far, I'm seeing no correlation. I don't see that the low priority items take longer, that the high priority items take shorter. That's what I would expect to see. But if we can reduce that number down, if we can say there's only 2 priorities, we've got regular work and we've got expedited work. Now it does become clearer and we can start to see, well, expedited work does get done faster. So we can color code that. So this is my general advice to teams is reduce the number of priorities that you have. If at all possible, take it down to 2. We've got standard and we've got super important, and that's it. Because as I say, when I graph all of the priorities together, I see no correlation.
Yeah, one
In
thing
this
you can think
case,
about is if you
go ahead.
focus on rank instead of priority, it forces you into a more meaningful conversation. This item is ranked higher than the other.
Yes, that is true. But in a general system, if we really want to get to be flow efficient, the algorithm we should use is the longer it's been in progress, the more important it is. So the item that's been open for 30 days is more important than the item that's been open for 2 days. That will give us the
Or it's
highest
no,
flow efficiency.
yeah, or we might have an insight that it's no longer important. It's just sitting there.
That's true. Yes. Yeah, it might be that it should have been canceled and it just didn't get canceled. That is true. But this chart here is showing, assuming that we only had 2 different flavors, we have normal and we have expedited. This chart is showing the expedited work. So really the thing I wanted to illustrate with this is this team has far too much expedited work. So we have some issues with priority because as we all know that if everything's urgent, then really nothing's urgent. And this is a team that had a lot of stuff urgent and it was staying open for a really long time. Look at these ages. This item's been open for 200 days, 200, 300 days, and yet they claim it's urgent. I really don't think it is. I think we forgot about that when we forgot to cancel it. So this is what this data is. The dashed line here is also interesting because these teams came along and after 500 days, they decided it wasn't important anymore or it wasn't urgent anymore, but they left it open. They didn't close it. It didn't get canceled. It just wasn't a priority anymore. So fascinating to look at the patterns that we see in here. All right, so let's talk for a quick moment about estimation. We tend to, we humans are inherently bad at estimating. If we want to be able to estimate upfront and say this is how big a piece of work is, uh, really there's no correlation between how long, what our estimate was and how long the work took. And that has a lot to do with what's on this chart. This is John Cutler's diagram, and I just love it because we tend to put an estimate on and we say, well, we think the level of effort is this, and we think the complexity is that, but what we don't take into account is how many other things were we doing at the same time? How many interruptions did we have? How many dependencies did we have? How many other things came along that interrupted us? And so the estimate is only talking about the work, but it's not just the work that affects how long it's going to take to get done. There's all these other things. If we look at Google Maps, for example, it doesn't just say, well, you want to go to the airport, it's 50 kilometers to get to the airport and you're driving at 100 kilometers an hour, therefore it's going to take you half an hour. No, they take into account how much, what the traffic typically is at that time of day, what the weather patterns might be. They take the environment, the full context into account. They do a forecast, not an estimate. So this is all just a great lead in to saying teams are really bad at estimates. So if you've got your teams putting story points on all of your stories, they're almost certainly wrong. And that's what this chart is all about. This chart is showing us how wrong we are. Because when I come into a team and I say, story points are really not a good use of your time, everybody pushes back and say, no, they are, which is why I show them this chart. And I say, okay, here's a 2-point story. That's a 2-point story, and it took us a day. And this is also a 2-point story, and it took us 2 days. And this is a 2-point story, and it took 3 days. And here's a 2-point story that took 4 days. And a couple more 2-point stories took 6 days. And a couple of 2-point stories took 11 days. And you got one out here at 14 days. So there's no correlation. And until I actually graph it, nobody really believes. This one here is a much larger data set, the one at the bottom. But again, it's showing the same idea. There's no real effective correlation between the estimate and the actual time it took to get the work done. And it doesn't matter whether we're estimating in the story points or t-shirt sizes or hours or whatever. The fact is, estimates are inherently inaccurate. And this chart is here to hammer that point home. So the last thing that the tool generates is this report. So Jira allows you to establish, here's a ticket and it's related to this other ticket in this way. It depends on this other one. It's satisfied by that. It's blocked by this other thing. It must come before this other. So it allows you to put all of these links, but then Jira doesn't actually show you the links. It gives you no coherent view into what that relationship is. And so we spit this out. We say, here's your relationship. And it is just a useful way of looking at what's going on. We can also see that we've got some things that are closed already because there's a line through it. So it's sometimes good to see the big picture. This is a team that doesn't have a lot of dependencies between their issues, and that's great. Sometimes we get such a mass that it would take a whole wall of printouts to make sense of what's going on. All right, so really, I've been talking a lot about Kanban here. But what if my team doesn't use Kanban? So yes, we also have a chart that shows burn downs. We show on some of the charts, we show specific Scrum specific data. So if you did have, obviously the one about story points was pretty much Scrum specific because Kanban teams don't typically do that. But there are a number of the charts that if you're in a sprint, it will show sprint data. So the aging chart will say this item has been in 4 different sprints. It kept carrying over from one sprint to the next, to the next, to the next. So all of this stuff is equally applicable for either a Scrum or a Kanban team. I built it mostly for Kanban teams, but there's lots and lots of good stuff in there for Scrum teams as well. Just a quick note, some people hate all the bright screens, and so it does work with dark mode. Everything is customizable. So if we want to say, my team considers the clock started at this point and considers the clock ended at that point, it's all configurable. So you can set it up any way you want. You can say, we start when you enter this column, or we start when you enter this status, or we start when you added this label. However you want to do that, it's all fully configurable. Issues can be excluded. We can change the orders of the reports. There's lots of different things. You can mix up the charts. We can show the same cycle time scatter plot in multiple different views, but just color code it different ways to highlight different things. So there's a lot of customizability here. Everything I've talked about up till now has been talking about a single team, a single board. But sometimes we want to be able to look across projects. And this does the same thing. So now this is a case where we've got 3 separate boards for 3 separate teams. And we've aggregated them all together so we can start to see the patterns. We can start to see what's going on. This is also valuable. So there's a lot of different charts that we can do around this. If you are doing some kind of a scaled model and you've got an S2 or a Scrum of Scrums, this is the view you'd want to see. I want to see across my teams what's going on there. Where do we have aging work across teams? And so this allows us to do that as well. But what if you might be asking, well, all these charts were pretty and the colors are great, but really all I want is raw data. I just want to know, extract that. And so, yes, this is an example of data that got exported. The tool will spit out CSV files with all of the stuff that you want. In this case, somebody wanted something for actionable agile, which is a great tool if you're using it. So we needed to pull the data out of Jira so that we could put it into actionable agile. And this is an example of the output that came out of that. So that, in a nutshell, is the whole system. Now, what questions do you have? just unmute yourself and let's chat.
I had a question that's kind of I don't know, a nitpick, but really kind of getting into details that may be overly fussy. So when you're looking at, time in progress and things going into in progress and then into blocked or stalled, uh, is there any sort of tweak that you need to do with regards to like if something is transitioning, say, multiple times in the same day? Like if it starts in progress and then goes stalled, but then someone comes back in and puts it back in progress. Does that?
Well, okay, stalled in particular, we look at the history. So I've pulled 9 months worth of data. And if you didn't do anything for 5 minutes, but then you did do something, it'll never get flagged as stalled because it has to pass. Well, we have to look forward a full 5 days and say, yeah,
Mm,
nothing happened for 5 days. So I counted you as stalled at the beginning. But if we wanted to, if we moved in and out of blocked status, for example, that would be a better example. So I move something into blocked and then I pull it back out of blocked. We're still tracking everything by timestamp. So you'll see that it did go in and out of blocked on a regular basis. For the charts that look a day at a time, if it was in blocked at all, even for a couple of minutes, it'll show as blocked for that day. But the charts that are not doing day by day, then you'll see the exact pattern of, well, on this hour it went in, and on that hour it went back out. So it is tracking everything by actual timestamp, not by day. But sometimes when the chart is looking by day, like some of these aging charts. Let me find one. Oh, yeah. So these are actually, this is the data for a single day. And so I would say if it was stalled at all for that day, it's going to flag as stalled. If it was blocked at all that day, it'll show as blocked.
I would
Did that
imagine
answer your
in the
question?
aggregate, it doesn't matter too much, but I was just kind of curious about, getting into the details on how that gets reflected.
Mm-hmm.
Yeah, in a certain sense, it doesn't matter, like some of the micro statuses. It's either to do, in progress, or done. And if it's blocked, it's still in progress, right?
Mm-hmm.
So what I like to do is think about, can we run a Kaizen or something on that, map out what the process is, figure out where the waste of the waiting time is, et cetera, and then we can try to relieve that. And what we'll see is our in progress will go down over time. I
Right.
mean, our cycle time for in progress. And the other thing is, I think that looking at a cumulative flow diagram shows so many of these things all in one place. Where
Mm-hmm.
if you see the stack of the to do, in progress, and done, and then you measure the horizontal distance between when something moved, from to do to in progress, and then where it crosses to being from in progress to done, you understand your cycle time. And so you clearly understand then it's basically the littlest law type thing, that the more that's in progress, the longer our cycle time is.
Mm-hmm.
So it's kind of a one-stop shop, if you ask me, at CFD.
It is, and there's a tremendous amount of useful data in it. The real gotcha with the CFD is that most people can't read it. I mean, obviously, there's people on the
Oh,
call here who do know how to read that, but I find that your typical team, they look at it and they glaze over. They have no sense of how to actually interpret that, and that's why I don't include that as one of my standard reports.
all right. I don't know. It's like, I think that's a training opportunity.
Yeah. But my goal is to display things in a way that everybody easily understands. And yes, people should learn how to read a CFD. No question about that.
Mike, a question. You mentioned misuse of epics as buckets versus not. I'm curious about
Yes.
that part.
Well, when we just use epics as buckets, we're throwing away any of the value that we might have got out of them. So if an epic is a unit of value all on its own and actually comes to completion, then there's a whole bunch of things we can do. So we can start looking at the focus of, are we actually completing one thing and getting it done, moving on to the next? We can start to do things like a Monte Carlo forecast across epics at an epic level. There's a lot of useful things we can do if we've grouped our epics usefully. If we just said it's a bucket of stuff, well, then all of those things go away. It might still be useful in the context of we've grouped things, we've categorized them, but we can't do Monte Carlo across them. We can't see if we've really got good focus. So we've thrown away a lot of useful information, is really the essence of it.
Are there any reports for epics? Because we use epics a lot for deliverables, and also we group bugs in a sprint under epic because we want to know how much we're spending on bugs versus other work percentage-wise.
So the short answer is any of these reports could be done against epics. By default, we filter out the epics and we look at stories only, but we could have just only pulled in epics, and then we'd be doing cycle times across epics, and we'd be doing aging across epics, and it would be all the same charts just pointing at different data. So that's the short answer. But it does assume if it's a bucket and it never closes, then there's no value in looking at an aging report for it.
Thank you.
Yeah, an example would be like having an epic called bug fix. It's never going to get done. And so how do you know what cycle time you're doing that, right? I like to think about stories and epics being some description of an outcome instead of being output type outcomes. And then we can do like an epic burn down, for instance, we might be another chart to look at. Similar to story burn down or points burn down within a sprint. We think about how much effort and what progress we're making, or we plateau off target.
Right. So if we assume that the epic has a lifetime, that it does in fact finish, then we can do all these interesting things. We can do the burn downs. We can do the cycle times. We can do the Monte Carlo. We can do all of those kinds of things. But if it's just a bucket, then all we can do is categorize.
So does JiraMetrics have a Monte Carlo report or calculation?
No, Monte Carlo, I don't have that built into this. The next version that'll be released does do a little bit of forecasting in terms of on the aging page. It's going to tell you this item is likely to take another 3 days, but that's the closest. We're not going to do full-blown Monte Carlo because there's other excellent tools that do that already. Troy McGinnis has a brilliant spreadsheet at focusedobjective.com that does all of this stuff. My tool can export all the data. You can just drop it into Troy's spreadsheet and away you go. Actionable Agile is also a great tool. Obviously, it costs money, but it is also a great tool that will do forecasting. So there's enough good tools for it that I didn't feel I needed to fill that hole.
Actionable Agile is a good plugin to get things like.
Yeah, I've used Actionable Agile quite a bit in the past, and I've been very happy with it. I've also used Troy's spreadsheet and been very happy with that.
I have one more. So you've seen multiple teams when they don't have the skill of even reading, understanding the charts or the data, right? So in your experience, how long does it take for a team to learn all of that stuff on their own versus like if, let's say, you come consult? Is that like a week long of interacting or maybe a couple hours here and there every week for a month or two? Just getting an idea of how fast this becomes useful for teams.
It can be tough. If I'm coming in and coaching a team, I usually start with an hour, and I'll just say I'm gonna generate. I don't give them the generics that I just did for you. I say this is your data. I'm gonna walk through your report, and we're gonna dig into it, and they're gonna ask questions about, well, why is this item so long? Well, let's take a look. Let's open up Jira, take a look at why that one took so long. So an hour is a good introduction. They're only going to absorb part of that. So it's going to be constant reinforcement. So at the next retro, we might say, well, we want to improve, so let's actually look at our current state. Let's pull up some data and take a look at that. And it will take time over time. My goal with this particular tool was that it should be educational. I didn't want you to, very clearly, I didn't want only experts to be able to look at the output report. I wanted somebody who was a beginner. And so there's a lot of verbiage around all of the charts saying this is how you read it and this is what's going on. Because my intention is that they can use this as self-learning. How effective I am at that is a whole nother question. I don't know. I would need to get feedback from people who haven't been coached, who have only seen the chart. But that's my goal. My goal is for this to be educational.
Awesome. I want to be respectful of people's time. Mike, thank you. Thank you so much for talking and presenting this. There's a lot of good stuff in here. Um, I'm looking forward to playing with it and yeah, and seeing how it can help. I'm also going to be sending out a link to this to a number of people that I know. So yeah, thank you so much. I'm going to stop recording this.